Hello, everyone. Welcome to this supplemental video. This is meant to be a instructional video for basically how to solve problems related to equilibrium, where we don't know the concentration at equilibrium of any of our products, but we do know our K value. And so I'm going to do this with number 13 on our in-class worksheet for chapter 13. And so in this case, we have a chemical reaction here. And then we have a K value given to us. We're also told the initial concentration of our reactant. And the thing we're asked to find is the concentration of Cl2 at the same temperature once we reach equilibrium. Okay, so the two things I would recommend doing to start any of these problems, which is going to be true for really any equilibrium problem, is write out the chemical reaction and then write out the K expression. And so I'm just going to start by rewriting the chemical reaction. So SO2-Cl2, gas is in equilibrium with SO2 and Cl2. And because everything is in the gaseous state, we know that we want to include all of these species in our equilibrium expression. If I write that, I can say, oops, sorry, K is equal to concentration of SO2 times the concentration of Cl2 divided by our concentration of SO2-Cl2. So this is just products over reactants. In this case, our coefficient for every reactant and product is 1. We don't need any additional exponents. Okay. So at this point, we can build our ice chart. So just remember, ice chart is initial change in equilibrium concentrations for all of our reactants and products that are included in our equilibrium expression. And so we're told that we start with 0.175 molar of our SO2-Cl2. Because we're not told anything about the concentrations of our products, we can assume that they start at a concentration of 0. Okay. We can then factor in the change, and since we know we have no product to start with, we will add some amount of product, and that will, of course, then come from the change in our reactant. All right, and then at that point, for our equilibrium, we just combine those first two rows. And so for SO2-Cl2, 0.175 minus X, then 0 plus X for both of these is just X, right? So now at this point, because we know K, we can plug in our unknowns. And so in this case, K is equal to, sorry, let me rewrite this here, erase that, and say that K is equal to, pen, 2.99 times 10 to the minus 7th. Then if we plug in our equilibrium row, so plug in this row's values into our equilibrium expression, we have X for our concentration of SO2, X for our concentration of Cl2, and it's going to be divided by 0.175 minus X. Okay. In this case, we can actually make our lives easier. So anytime we have a K value that is less than 10 to the negative 4th, so 1.0 times 10 to the negative 4th, which in this case it's 2.99 times 10 to the negative 7th, so quite a bit smaller than 10 to the negative 4th. Or if our K value is larger than something times 10 to the 4th, then in that case we can use an approximation that is called X is small. And so what X is small approximation does for us is it tells us that we can ignore the X in our denominator because the change in X is going to be small relative to this initial concentration of 0.175. Okay. So that is when we will ignore x. Again, it relates to our constant here whenever it is less than 10 to the fourth, or I should say greater than 10 to the fourth. Okay? If it's between those two, then you don't get to use the x is small approximation, and that will be true for things like problem 12 on our in-class worksheet here. Okay, so if we ignore that and then multiply both sides by 0.175, I got values of 5.232 times 10 to the minus 8th being equal to x squared. We then take the square root of each side to get rid of our squared there. I got an x value equal to 2.29 times 10 to the minus 4. Okay. And since we've solved for x, and we know that at equilibrium, x is going to be the concentration of our products, we can say that x is equal to the thing we want to solve for, concentration of Cl2, and that'll be equal to 2.29 times 10 to the minus 4th molar. Okay. Right. I hope that was informative. If you do have questions, please let me know. We'll continue to go through this in class, but feel free to rewatch if you have any questions. Otherwise, I will see you in class.